that, or it tells us that a particle is moving along the x-axis so that at any time t greater than 0, its position is given by this function. And you have it where the positive x-axis is going to the right, but it's asking us. I'm assuming, yeah, that the positive for what values of t is the particle moving to the right. That's when it is that the particle is moving to the right along or moving up, right? The x values are getting larger and larger. Now, we could reinterpret this question so it just simply says, for what values of t is the velocity positive, right? For what values of t, what values of t is v of t greater than 0? Because that's essentially saying, right, these two things are implying one another. The particle is moving to the right if the velocity is positive, and the particle is uh, not moving to the right if the velocity is not positive. So the only thing we need to get is we need to find out where the velocity is positive. In order to do that, we need to know only this physics fact, that the derivative of its position is the velocity. So I need to find x prime of t, which is v of t. And I'm going to do chain rule here. I'm differentiating with respect to t. A is a constant. They deliberately tell me that. This serves as like u in my chain rule. So the 2 comes down times a half becomes 1. This exponent becomes a 1, and the inside stays the same, so it becomes a minus t times the derivative of u. The derivative of this, the derivative of a is 0. The derivative of negative t is negative 1. So this becomes times negative 1. And all that times negative 1 does is flip the signs. So it becomes t minus a is my v of t. Now, I want to find out exactly when it is that this is greater than 0. And the condition for this being greater than 0 is provided that t is greater than a. And that is said in b. A is less than t, same thing. If only if a is less than t, you could read this from right to left, a is less than t.